is time for some fundamental ideas behind chemistry. These are things that are very helpful to chemistry. They might not be specific to chemistry, but chemistry does have some mathematics involved in much of it, so it is helpful to do some of these things. And this specific video, I'm going to talk about scientific notation. Scientific notation has a very specific format to it. Okay. And it involves how you express the number and the number of significant figures it has. So I want to start with an example and explain as I go. So let's look at the number 5,264. We are going to express this in scientific notation. So one of the first things we do is we recognize how many significant figures it has. In this case, it's got 4. The way that we always express numbers in scientific notation is that there is a number, the first value, okay, decimal point, followed by however many significant figures remain past the decimal point. In this case, 2, 6, 4. Get these 3. Okay. And then we express this value, 5,264, in this way, where what is 10 raised to a power that you need that when it is multiplied by 5.264, that it would give 5,264. Right. So in this case, if we were to multiply this value by 1,000, or in other words, 10 to the third, we would get this value. Okay. So scientific notation is always expressed in this way. One value will be there before the decimal point. So, for example, we would never see it written as 52.64 times 10 to the second, or 526.4 times 10 to the 1, which in other words is just 10. Okay, but rather the decimal point's always there. Okay. Now, one thing that can be tricky, and I see this with my students a lot, is trying to figure out, is it 10 to the third or is it 10 to the minus third? And I see this mistake so often that I decided it would be good to go over this aspect. See if we can clarify it a little bit for you. Okay, but let me erase this now. So let's look at some examples. Let's say we have this value here. Okay. 0.0030. First, I will ask you, how many significant figures does this value have? The answer is 2. These 2 are significant. These zeros are placeholders. This 0 here, which some people don't put, you really should. Formally, it should be there. But then there's your decimal point. This is a placeholder for the tenths place. Here's a placeholder for the hundredths place. Here's a significant digit. And when you do see a 0 after a value that is between 1 and 9, then it is signifying that it is a significant digit. Okay. So now let's write this in scientific notation. So as always, we choose our first significant digit. And if there are any significant digits after it, we include that after decimal. And now our job is to express it in such a way that we are multiplying it by 10 raised to a power that will give us the original value. Okay. So in this case, we have 3, which is a value that is larger than 0.0030. So that means we need to multiply 3 by a number that is smaller, that's less than 1. Okay, 10 to the minus 3. Maybe it helps if we remind ourselves what this means. When we write 10 to the minus 3, what is that equivalent to? That is the same as writing this. Some people do this to show decimal point is moving to 3. Okay. 10 to the minus 1, 10 to the minus 2, 10 to the minus 3. Okay. And if you were to put into your calculator 0.001 times 3.0, you would get 0.0030. So that can be your test. After you've written a number in scientific notation, if you actually go back into your calculator and put in this first value and multiply it by 10 to the power that you think that it should be, you should get that original value. Okay, so that's your test that you wrote it correctly in scientific notation. Okay. Perhaps let's go the opposite direction. Okay. Let's say we have a number such as 1, 1, It's funny, that looks like a Z, but I want it to look like a 2. I'm going to make this curve here a little bit. Okay. So, if we consider what this value is, 10 raised to the 2. Okay. This value, because now we have 10 raised to a positive value. This is 10 squared, isn't it? Which equals 100. Okay. This value is now going to make this part of our numerical value that was written in scientific notation. We'll make this larger. In other words, we're going to move the decimal point over twice. 1, 2, because it's 10 to the 2. This would be equal to 7, 1, 1.4. Okay. So hopefully this is helpful for you, seeing these examples and going in each direction, having a number, writing it in scientific notation, or having a number written in scientific notation and writing it in a, I guess you would call a regular kind of way, not using scientific notation. All of this takes a lot of practice, so I recommend that you try some problems. You can always look in the back of usually the first chapter in a chemistry textbook. Has lots of problems that have scientific notation and metric prefixes and significant figures. All those are very helpful in chemistry. Believe me, they help you a lot. So, thank you. Let me know how you liked the chalk, the little chalkboard I got. This chalk I got is supposed to be really good. It's called Agoromoto. It's Japanese chalk. I heard it's the best. I'm not sure. I think it's pretty good, but honestly, I am not a chalk connoisseur, so I'm not really sure. But so far I'm liking it. So, all right, let me know what would be helpful for you. And I also wanted to invite you to subscribe to this channel. And the reason is that the more subscribers I have, then these videos that I make will get suggested to other chemistry students and hopefully will help them. I don't make money off of this. I've made maybe a few pennies if you divide it over the course of the 4 years. So I'm not saying that to make money for myself. It's to help people. So, and hey, maybe someday I will make some money off of it. That would be good, but I'm okay either way. All right. Well, with that, take care. Always give me your requests. I will try to honor them. Sometimes it takes a while, but I will try to get to them. Thank you so much, and thank you for all your messages you leave for me. I just love them. And I will see you next time.